So significant digits or significant figures. Means the same thing. Sometimes I say sig figs. Sometimes I say sig digs. But more than likely I say sig figs. And I mean significant digits. So, these are numbers associated with measurements. If you have a count of something, it has an infinite number of significant digits. So you don't use that value to round significant digits. Like if you have H2O, how many atoms of hydrogen are there? 2. That is a count. So it has an infinite number of significant digits, so it will not play into the rounding of any number that you use it with. So, answers cannot be more precise than your least precise value. So if I'm measuring something in kilometers, I can't report it to a meter because I wasn't measuring it in meters. If I am measuring something in meters, I cannot record centimeters because I did not measure in centimeters. So you can't represent your answers more precise than they actually are. And it's not the same thing as accurate. Accurate means you got the right answer. Precise, how close you are. Okay? So, who's significant? Numbers 1 to 9 are always significant. Sometimes these are called non-zero numbers. I'm going to call them numbers, 1 to 9. Okay. The tricky part here is zeros. Zeros are significant if they're between numbers 1 to 9. So if you find zeros in the middle of a number, they are significant. Okay, zeros are significant if they're between numbers. Zeros that are leading zeros are not significant. Do you know what a leading zero is? A leading zero.
The ones like before number?
Yes. Any zero before the first number between 1 and 9 is called a leading zero. So leading zeros are not significant. Do you know what a trailing zero is then? Thank you.
0 after the number.
Yes, so zeros at the end of a number. These are significant only if there's a decimal place somewhere. So trailing zeros are significant only if there is a decimal. That number. It should be a 5.
So 415.
It's supposed to be 415. How many sig figs? 3? Yep. 3 sig figs. How about 4,015?
4.
How about 3? Do you agree? Yep, 3. These are what are called your leading zeros. They come before the first non-zero number, the first number between 1 and 9. So what they do is they just tell you in which column that 2 is found. All right, how about 0.120?
3.
Do you agree, Emily?
Yeah.
Oh, your voice got deep there. How about 1,200?
2.
Why? Inca?
Because the zeros are only significant. There's a decimal. There's no decimal point.
There's no decimal point.
Well, it'd be a thing.
There's no decimal point here. So these two are just placeholders telling you which column the 1 and the 2 are in. If there was a decimal, that means they've been measured. This could be 1,198. Could be 1,204. It's been rounded off, possibly. Okay, so we don't know how accurate that number is. Now, how about that number?
1.
There's only one significant digit. The rest are important. That's 100,000. Right? You don't want somebody to mess up on a paycheck and pay you in pennies instead of dollars. So they count. They're just not what we consider significant. All right, so how about this one? There's 3, because now there's a decimal place there.
Then we know.
All right. Now, you're going to have a lot of questions in the next unit where you have to round off your final answer to the proper number of significant digits. So, when rounding off, pay attention to the first digit to be dropped. So you've got to pay attention to the first digit to be dropped. So if I have 12.623 and I want my final answer to have 2 sig figs, which numbers am I going to have to keep? Which one is the one that's going to be the first one to be dropped? Which number is going to be dropped? Brandon?
The decimal?
So, this here is the number that's going to get dropped. So you have to pay attention to that number. What about, oops. $15.405, and I want to round to 3 sig figs. Thanks, Nick. Hello, Sasha. Which number is going to be dropped? Which one out of all of those? The 0. This number right here, the 0. So, there's rules. There's rules. And I'm sure most of you know these. So, if the number to be dropped is less than 5, if the number to be dropped is less than 5, leave previous number alone. If the number to be dropped is equal to, or greater than 5, round previous number up. I'm going to put a star beside this because there's a funny rule with a 5. If a 5 has only zeros after it, or there's nothing after it and it's the number to be dropped, we have a special rule. So, if number to be dropped is equal to 5 with zeros or nothing after it, then we've got two things. If the previous number is even, we leave it alone. If the previous number is odd, we round it up. The end result is you get an even number. So, if number to be, I was thinking 5. If number to be dropped is equal to 5 with zeros or nothing after it, and previous number is even, leave it alone. if previous number is odd, round it up. Basically, we're trying to even out all the rounding that occurs with fives in the universe at any given time. Because if there's a 5 with something after it, you round it up. So if it's nothing after it or zeros, we have this weird rule, okay? So we're okay with this? You want some here. If I have 14.25 and I want you to round to 3 sig figs, what would your answer be? What would your answer be if you were rounding 12.55 to 3 significant digits? What's the number that's going to be dropped in the first question? Income?
2. Oh,
That's-
the 5.
The 5 is going to get dropped. What is the number to be dropped in the last number up there? 12.55. The last 5. All right. Are there zeros behind this? Nope. Are there numbers behind this? Nope. So you're not rounding up like you used to do until you took physics. And math changed forever. 14.25 will become 14.2. 12.55 will become 12.6. And the hope is that we are evening out all the rounding that's going on at this exact moment in time around the world. So, we have special rules for 5s. Okay, so using significant digits. Multiplying and dividing. So you're going to look at the number of significant digits in the initial data. So if you're given a problem, you're always going to go back to your initial data. And you will round final answer to the least number of significant digits in the data. For instance, yes, do the math. Write down an answer. By the way, your calculators are dumb. They drop significant digits when there's zeros. Is there something wrong with my water? Uh-oh. Shoot. Okay, what number did you guys get? 27.2. All right. How many significant digits here in the first value? 2. How many in the next value? So the lowest number of significant digits is how you're going to record your final answer. So you have to round your final answer to 2 significant digits. So your answer is 27. Oh my God. Okay. How about 154.0 divided by 2? So your final answer, you would have to round to 80, right? Because you can only have one value in your answer. Are you okay with that? This is where I see people make mistakes, is you report the one number and you forget about the actual value. People would put down 8, like the multiple 80 doesn't count. So be careful when you're reporting your answer. Either use zeros to show which column that's 8 is in, or put it in scientific notation. When we're adding and subtracting, we have to look at the position. So add 120.0 plus 2.35. Now, when I teach you this rule, it's easier if you do put it in columns until, some of you already know this rule, but for those of you that don't, this is the best way to explain it. So, 120 plus 2.35. Without rounding, what is that answer? 122.35. But this second value of 2.35 is more precise than the 120.0. Your final answer can't be more precise than your least precise number. So, you go to the last number for each value. The one that's furthest to the left will be the position that you round to. So this is the tenths, this is in the 100ths. This is the most to the left, so my final answer has to be rounded to the 10ths position. So you would round that answer. You have to drop the 5. So it's 122.4. Oh my God. Okay. Are we okay with that? Do you want to do another one? 46.1 and 2.325. This is rounded to the tenths. This is rounded to the 10,000ths. So, Ankit?
48.4. You're gonna drop the 2.
48.4. We're dropping the 2. It's less than 5, so we leave the previous number alone.